Currently, there is no unified or clearly defined standard for what constitutes artificial general intelligence or general agentic AI. Interpretations of the term general vary widely across the field, which has led to a range of differing predictions and expectations within the industry. If we define general agentic AI as achieving human-level performance across multiple distinct domains, then such a goal may be within reach shortly. However, if we define it as an idealized, fully capable system, one that can handle virtually all human cognitive tasks, rapidly learn and adapt to any new domain, grasp objective physical laws, understand spatial structures and relationships in the world, interact with the physical environment, and continuously learn, then such general agentic AI would require years of technological development and breakthroughs. That said, regardless of the chosen definition, treating general agentic AI as a long-term, exploratory scientific goal remains both reasonable and necessary. Current debates over the applicability of general agentic AI in vertical domains primarily stem from the immaturity of existing technologies, which are still far from achieving true general intelligence, and flawed analogies drawn between human cognition and the capabilities of artificial agents. A truly general agent should possess robust learning and generalization capabilities, enabling it to rapidly acquire knowledge in vertical domains and apply it effectively across a wide range of specialized fields. In addition, the challenge of limited domain knowledge in vertical fields can also be addressed at the system level, leveraging various mechanisms such as memory systems, external knowledge bases, and tool use to compensate for gaps in specialized knowledge. Flawed analogies based on human limitations should be avoided. Given their advantages in computation, speed, and memory, AI agents could, in theory, rapidly acquire knowledge in any domain, provided sufficient energy and advanced learning methods. In the long run, general agentic AI is likely achievable given current technological trajectories. That said, the journey will be highly challenging, and its ultimate manifestation may diverge considerably from our present expectations. The core of general agentic AI lies in its ability to integrate several key capabilities, including full multimodal perception and understanding, spatial intelligence, including world cognition, comprehension, causal reasoning, and prediction, physical world interaction, continuous learning and evolution, and adaptability to diverse environments with broad task-solving capabilities. While current technology falls short, significant research is underway, such as in multimodal large models, continual and lifelong learning, world models, embodied intelligence, and humanoid robots. Advances in large models, generative AI, combined with computing power, energy efficiency, and algorithmic innovation are driving a spiral of advancement, accelerating progress toward general agentic AI. Moreover, general agentic AI is unlikely to be a single, static, omniscient, monolithic model. Instead, it will likely be a dynamic, collaborative system built upon multiple powerful foundation models, leveraging world cognition, reasoning, prediction, and decision-making to understand tasks and coordinate specialized models, tools, databases, and services. The system's generality will manifest in its broad adaptability, autonomous planning capabilities, flexible and dynamic resource integration, and continuous self-learning, enabling it to progressively enhance its ability to solve a wide range of previously unknown problems. Model size, response time, and generality are interdependent. Scaling laws in AI suggest larger models with more computational resources yield stronger reasoning and generality, but an increase in latency. As the core module of an AI agent system, the model plays a critical role in determining the system's overall performance, generality, and response latency. Balancing these requires considering the application scenario, intended objectives, and user requirements. Architectural innovations, for example, mixture of experts MoE, novel model structures, and model compression, algorithmic optimizations, such as inference optimization, caching, and pre-computation, and hardware design, for instance, hardware acceleration, can help strike an optimal balance among these conflicting objectives. Well, I believe agent access in the AGI-IASI era will most likely take the form of a hybrid model, combining a unified agent interface with ubiquitous lightweight agent endpoints. Each serves different purposes and scenarios, and their coexistence and coordination will best meet diverse real-world needs and deliver optimal user experiences. As technologies such as AIoT, smart wearable devices, and intelligent home systems continue to evolve, AI is becoming deeply embedded in our daily lives, turning every connected device into a potential access point for agent interaction. These smart terminals support natural forms of interaction such as voice, gestures, posture, facial expressions, and even eye movements. Lightweight agent interfaces are especially well suited for contextual and personalized scenarios. For instance, smart earbuds that recommend music based on user preferences, or smart glasses that provide information about the object in your view. These highly contextualized, efficient interactions are best enabled through ubiquitous, lightweight entry points. Moreover, due to concerns like data privacy and the need for low-latency responses, some agent functionalities must operate directly on edge devices. This reinforces the need to distribute intelligence across terminals, making agent interfaces inherently decentralized and omnipresent. At the same time, a unified agent interface also holds essential value and is indispensable. First, a centralized mechanism is needed to coordinate the behavior of decentralized agents, ensuring task and contextual consistency across devices. Second, a centralized agent can manage the vast amounts of personal data, like preferences or habits, collected by edge agents, ensuring consistency, security, and a uniform user experience across devices. Finally, for complex tasks that involve multi-source information, deep reasoning, and long-term planning, a centralized and comprehensive agent system is better positioned to handle such challenges effectively. In summary, lightweight entry points will become ubiquitous with the proliferation of smart devices and enhanced agent capabilities, enabling situational awareness and personalized interactions. The unified agent interface will coordinate multi-device agent behavior, maintain data consistency, handle complex tasks, and manage user privacy.